Okay, good morning 3G. Today I'm going to touch on a new topic. It is called binomial theorem. Okay, so the first part of this binomial theorem is actually introducing to you something what we call the binomial coefficient. So, but it is not going to be tested in the exams. Alright, so I just want you to take it with a pinch of salt, and if you don't understand, it's fine. We'll move on. I'll be covering 6 pages of the binomial notes today, which is worksheet number 5. Now, binomial theorem is invented by this guy called Pascal. He also invented pressure. If you remember, pressure is force over area, which is the units is Pascal. It's named after himself. He's also the one that invented binomial theorem. Now, before we start on binomial theorem, I want to expand something for you. In secondary 1, we have learned that 1 plus x to the power of 1 is 1 plus x. No problem. 1 plus, we learned in secondary 2, 1 plus x squared. 1 plus x squared, if you expand, is 1 plus 2x plus x squared, which is great. Now, in secondary 3, we are going to learn how to expand 1 plus x to the power of 3, 1 plus x to the power of 4, 1 plus x to the power of 5, so on and so forth. And this is what we call the start of binomial theorem. If you observe, we can expand 1 plus x cubed by multiplying 1 plus x times 1 plus x squared. That will give us 1 plus x multiplied by 1 plus 2x plus x squared. If you were to expand using the rainbow method, this is what we will get. We will get 1 plus 2x plus x squared plus x plus 2x squared plus x cubed. If we simplify, I will get 1 plus 3x plus 3x squared plus x cubed. So I'm going to write it here. So it's 1 plus 3x plus 3x squared plus x cubed. So is it a very tedious way of expanding 1 plus x cubed? Yes, it is very tedious, and so on and so forth with 1 plus x to the power 4. The expansion is going to get bigger and bigger. That's why we are learning binomial theorem, to make our life easier, to expand without using the rainbow method. So I'm going to fill in 1 plus 3x squared plus x cubed. Here, in this case, it will be 1 plus 3b plus 3b squared plus b cubed. I'm going to give you the answer for 1 plus b to the power of 4, but I just want you to take a look at a certain pattern. See, it starts with 1, ends with 1. There's a hidden 1 here. Alright? Starts with 1, ends with 1. And the next thing I want you to take note, see? No b, b to the power of 1, b to the power of 2, b to the power of 3. And there's one more observation. See, 1 plus 1 gives you 2. 2 plus 1 gives you 3. 2 plus 1 gives you 3. Right? So, if you notice, it starts with 1 and ends with 1. So, you can start with 1 and end with 1. It's going to be a plus what? 1 plus 3 is 4. So, it's plus 4b plus 3 plus 3 is 6. And the next one is b squared. Next one, 3 plus 1 is 4. So plus 4b cubed plus, and it ends off with b to the power of 4. See? So this is how we expand binomial theorem. Well, is there a more efficient method? Yes, there is a more efficient method, and the method is called binomial theorem. Okay, now I'm going to go into the Pascal triangle. Now, do you know why is it called a Pascal triangle? Because this is shaped in a triangle. And well, Pascal is a French person, so He named it after himself, Pascal triangle. If I were to invent it, I'll name it Peter's triangle. But no, I'm not the one who named it. Okay, anyways, let's carry on with this triangle. Okay, like what I mentioned to you just now, if you notice, 2 plus 1 gives you 3. And it ends off with 1. It always ends with 1. And it starts off with 1. Okay, let's fill in the blank. Very, very simple. 3 plus 3 is 6. 3 plus 1 is 4. Continue. 1 plus 4 is 5. 4 plus 6 is 10. Here will be 6 plus 4 is 10. 4 plus 1 is 5. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. Alright? And if you were to take a look at here, what is all this? These are the powers. These are the powers. Okay? So basically just now what we did was power 3. This means 1 plus x to the power of 3 equals to 1 plus 3x squared plus 3x. 1 plus 3x plus 3x squared plus 1x cubed. Alright, so this one as well, this is actually 1 plus x to the power of 4, which is equals to 1 plus 4x plus 6x squared plus 4x cubed plus x to the power of 4. Well, you get the idea. Alright, so this is the Pascal triangle, supposed to help us with the expansion of higher powers. Now, we are supposed to observe some patterns in the Pascal triangle. If you notice, if I have power 3, I have 1, 2, 3, 4 terms. If I have power 4, I'll have 1, 2, 3, 4, 5 terms. So think about it. If it's power n, how many terms will I have? I will have n plus 1 number of terms. The first number of each row is always 1, and the last number of each row is also always 1. Write down an example of binomial coefficient to show symmetry. Now, if you realize there is some form of symmetry in Pascal's triangle. What do I mean by symmetry? See, I'm going to draw a line of symmetry here. Do you see this is 15? This is 15. 6, 6, 1, 1. See, there's some form of symmetry over there. Okay, but I'm going to use the 1, 5, 10, 10, 5, 1. So it's like 1, 5, 10, 10, 5, 1. It's a symmetry. Alright, you realize? Alright, so it always goes up in the middle, then after that from the middle it will go down, and it's symmetrical. The numbers are the same. Is this really, really very important? No, not very important. As I said, I'm introducing the topic to you and how binomial came about. Now, if I ask you to write down the binomial coefficients when the power is 20, are you able to do that? Well, you can do that if you have a lot of perseverance, but yeah, it's very, very troublesome. Yes, but it is very troublesome. It's possible. But what are some of the limitations? That means you have to write down, you have to work your way up to n equals to 20. Okay, and that's not something that we want to do all the time, because that's crazy. Right, let's move on, because this is not exactly very important. This is what we have went through with you just now. 14641. Okay, now there is a way to obtain the binomial coefficients efficiently. That means there is a way to get all these numbers, all these 1, 6, 15, 20, 15, 6, 1, very efficiently without using the triangle and work your way up. Now, on your calculator, you will be able to see this C here. I'm going to switch over to the camera. Now on your calculator, you'll be able to see this C button above the divide. Okay, we'll be using this quite a bit in the next lesson, next week. Okay, but in order to get the numbers that we see just now, we need to use this C button. Let us see how we can use it. Okay, let's take a look at this one. If it's power 4, in order to get 1, we key in the power, which is the 4, followed by the position. Now, in binomial theorem, it's very special. It starts with position 0, then followed by position 1. Okay, the power remains the same. The 4 is always the same. This depends on the power of whatever that you're expanding. This will forever stays the same. Alright? This one, this number, this square, this green square below, tells us the position. What position do you want? Okay? Position 0, position 0, position 1, position 2, position 3, position 4. Okay? So how do you key in, like for example, I want position 2. How do you key in 4, 2? Like this. On your calculator, okay, when we write it as 4, 2 like this. Okay, but on your calculator, we press it as 4C2 like this. Okay, so how do we press? So on your calculator, you press the number. Okay, you press the number 4. Okay, in order to press this C, you need to press Shift, then you press the C, which is this divide, and then just now we say 4C2, right? 4C2 you press, you get 6. Okay, if you want the next position, you press 4C3. Just press 4C3, and you get 4. Okay, going back to our notes. So you see, if I want the Pascal triangle of 20, I can easily write it out because I can just use the calculator to press 20C0, 20C1, 20C2, so on and so forth. So it wouldn't be a problem. See, just now we press 4C2, we get 6. It is 6. So we are able to use the calculator. So if we really want to know the coefficient of 1 plus b to the power of 20, we can do that. We start with 20 first. Then after that, the second one will be 21. Then the third one will be 22, so on and so forth. Of course, this one, 20, then you plus 21, there is 1b over here, plus 22, there is b square over here, so on and so forth. So we know the binomial coefficient of all the b's that we want to put in front, the numbers that we put in front of the b. Alright, so this is an efficient way to do it. I will skip this because I will instead show you how to do this. Okay, so this is 1 plus x to the power of 10. Remember, to the power of 10, we have 11 terms. We start off with position 0. So it's 10, 0. We start off position 0. They want only the first 4 terms. So this is the first one. The second one is 10, 1. Just the coefficient. The third one is 10, 2. The fourth one is 10, 3. Plus so on and so forth. And remember, we need to insert the algebra inside the x here. The first one is always without the x. The second one is with the x to the power of 1. The second one is x to the power of 2. The third one is x to the power of 3. So on and so forth. Now, to recap, okay, let us take a look. I'm going to scroll backwards all the way here. See, if it's power 3, it always starts with no x. Okay, start with no algebra. Then the algebra power 1, algebra power 2, the last one algebra power 3. Alright, so it's like this. This is binomial theorem. Scrolling back, if I were to continue, of course I can continue writing. It would be tan 4 x to the power of 4. If I continue, tan 5 x to the power of 5, so on and so forth. But I only want the first 4 terms, so we're going to work that out. I want you all to take out your calculator now and try to press tan 0. Okay, if you press tan C0, you should get 1. Tan C0, you will get 1. And that's just the number 1. That's the first term, done. Last, if you were to press tan C1, you'll get 10. So that's 10x, done. Last, the next one, if you press tan C2, you get 45. So 45x squared, done. The next term, tan C3, and you get 120x cubed, done. They want first 4 terms. First term, second term, third term, fourth term, and we are done. Alright, simple. Okay, let's do the next one. 1 minus x over 2. Same, this is power 8. I want the first 4 terms. I write down the binomial coefficient first. That is 8, 0. We always start with 0. Then we go into 8, 1. 8, 2. 8, no over. 8, 3. I only want the first 4 terms. The first one, no algebra. The second one, follow the algebra, which is negative x over 2. Third one, follow the algebra, negative x over 2, but this time with a square. Third one, follow the algebra, negative x over 2, with a cube. Now, let's work out our working. It's the same thing that I'm doing, except that this algebra is not just x, but it's negative x over 2. Alright? If you press your calculator, 80, you get 1. Plus, if you press your calculator, 81 is 8. But it's 8 multiplied by negative x over 2. Plus, if you press 8C2, you'll get 28. And negative x over 2 is x squared over 4. Because the negative will disappear because of the square. Negative times negative is positive. Plus, if you press 8C3, it's 56. Okay, negative x over 2 cubed is negative x cubed over 8. The negative remains there because negative times negative is positive times another negative is negative. Alright, let's try to simplify this binomial expansion. The 8 and the 2 can cancel. It will give you 4. Positive times negative is 1 minus 4x. The 28 and the 4 can cancel. This is 7, so it's plus 7x squared. The 56 and the 8 can cancel. This is 7, so it's negative 7x cubed plus dot dot dot. The first 4 terms. First term, second term, third term, fourth term. Alright, so this binomial expansion, I hope you understand. If you need some help, I need you to pause this video here and focus on this. Try this question on your own without copying from my solution. If you're not sure, take a look at this video again. There will be a part 2 to this video. That's the end of part 1.